So yesterday we worked with equivalent expressions. So today we're going to start with using equivalent expressions using exponents. Numbers expressed using exponents are called powers. For example, 100 is a power of 10 because it can be written as 10 to the power of 2. Numbers like 100 are perfect squares because they are the squares of whole numbers. So the blue square, that's 100, right? It's 100 little squares. So 10 times 10 equals 100. So 10 to the power of 2 also equals 100. Well, what about 10 times 10 times 10? That's 1,000. And so that would equal 10 to the power of 3 would also equal 1,000. Perfect cubes are numbers with 3 identical whole number factors, such as 4 times 4 times 4 equals 64. So the number 64 is a perfect cube. You can generate equivalent expressions using whole numbers exponents. Equivalent expressions have the same value. Let's look at an example. Number 1, for each of the following, generate an equivalent expression using an exponent. Okay, so 6 times 6. All right, well, we know that 6 times 6 is 36. And so 36 times 6 equals 216. And then we multiply our last 6. So 216 times 6 equals 1,296. So, like the question says, generate an equivalent expression using an exponent. That would be 6 to the power of 4. Let's look at our next one. We have 4 times 4 times 4. The factor blank is the base. Well, what are they multiplying? What are our factors? 4. So 4 is the base. The factor is multiplied how many times? 1, 2, 3. 3 times. The exponent is going to be 3. So 4 times 4 times 4 can be written as 4 to the third power. All right, so just how would you write 7 times 7 times 7 times 7? What can that be written as with an exponent? It would be 7 to the fourth power because we are multiplying 7 4 times. We can also use equivalent expressions using products. To write powers as equivalent products, determine the base and the exponent. The base of 10 to the power of 2 is 10, and the exponent is 2. To read powers, consider the exponents. The power 10 to the power of 2 is read as 10 squared, and 10 to the power of 3 is read as 10 cubed. Let's look at this example. Express 5 squared as a product of the same factor. Then determine the value. All right, it says the base is 5. The exponent is 2. Let me move this out of the way, sorry. So 5 is used as a factor 2 times. 5 squared equals 5 times 5. And so that equals 25. Let's look at this one. Express 1/2 cubed as a product of the same factor. Then determine the value. The base is 1/2. The exponent is 3. So 1/2 is used as a factor 3 times. So expressing a product of the same factor, you write out 1/2 times 1/2 times 1/2. And that would equal 1/8. So a reminder, a product of like factors can be written in exponential form using an exponent and a base. The base is a number used as a factor. The exponent tells how many times a base is used as a factor. So, for instance, let's just do 5. So I don't have my pen with me. I'm having to use my touchpad here. That's why it's a little wiggly. But 5 squared, the base would be 5. 5 is the base. and then the exponent is 2. This is the exponent. Okay? So how would we write 10 to the power of 5 as a product of the same factor? So what we would do is how many times? What's the base? Well, the base is 10. All right, you don't have to write this down. I'm just going to write down the base is 10. Oops. The exponent is what? It's 5. It's 5. All right. Let's get this over a little bit. So to write 10 as a product of the same factor, what we're going to do is we're going to do 10 times 10 times 10 times 10 times 10. All right, so 10 5 times. Well, what is 10 times 10 times 10 times 10 times 10? That's going to equal 100,000. Now, let's do some guided practice. You can pause the video, go get a pencil and a piece of paper if you want to. Actually, yes, go get a pencil and a piece of paper, and we can do this together. All right, welcome back. Okay, so we have 8 times 8 times 8. All right, so first let's write this with an exponent. So we would have 8 to the what power? To the third power. Okay, so that's what that equals. All right, let's multiply 8 times 8 times 8 and see what this product is. So we know that 8 times 8 is 64. Okay. And then once we've done that, we just have to bring this 8 down. That's a horrible straight line. Bring it down. And so then we have 64. 64 times 8. And so 64 times 8 is 512. So 8 to the third power equals 512. All right, let's look at another one. Here we have 1 times 1 times 1 times 1 times 1. First, let's write an equivalent expression using an exponent. So our base here is 1. There's my 1, my straight 1. And then my exponent is going to be 2, 3, 4, 5. It's going to be 5 because we are multiplying 1 5 times. All right. And so that is 1 to the 5th power would be writing an equivalent expression using an exponent. And to solve this, the product of this would be just, well, you tell me, if we multiply 1 by itself 5 times, what are we going to get? Well, the answer would be 1. All right. For this one, express each power as a product of the same factor. Okay, well, our base is 2 and our exponent is 5. So we would do 2 times 2 times 2, so horrible 2, times 2, and then times 2. We have 5 2's, right? 1, 2, 3, 4, 5. Yep, our exponent is 5. And so what would this equal? Well, we know that 2 times 2 is 4. And we know that this 2 times 2 is 4. So what's 4 times 4? Well, that equals 16. And then all I have to do is multiply this last 2 by 16. 16 times 2. What is 16 times 2? 16 times 2 is, let's see. If you already have it, great. I'm sorry. So I don't have it in my head right now. Actually, I probably do, but I just want to work it out. So 6 times 2 is 12. There's a 2. And carry the 1. And so 2 times 1 is 2, plus 1 is 3. So 2 to the 5th power equals 32.